Okay. Good morning, good afternoon, and good evening, wherever you are. My name is Dr. Thomas Kendall. I'm the application specialist for Technobis crystallization systems, and I'll be leading this webinar on the training on how to use the Crystalline and specifically the advanced analysis of the Crystalline software. So first I will share my screen. Okay. So what will be covered today will be how to capture high quality images. So this will primarily be with the settings that are in the Crystalline regarding the camera settings, so what we're able to change. Then we will move on to what methods of detection are possible.
You are not sharing.
Am I not sharing?
Yeah.
Ah, that's okay. Sorry about that.
Yes.
Share screen. Sure. Okay, now that should be sorted. Sorry about that.
Yeah.
Okay. So as I was saying, what methods of detection are possible and what their benefits of them are, and then how to analyze your data. Throughout the session, if you have any questions, please feel free to put them in the Q&A section of the browser. And then at the end, there'll be a question session where I'm happy to take any questions you have on anything you've seen today. It should also be noted that this training is recorded and will be made available for all attendees after the session. So first, I wanted to take this opportunity to say that we, in March, released a new major update of the crystallization software. This resolves many bugs and crashes that we were able to fix, as well as adding new features such as the feedback control based on particle count. So it's advised to update your system as soon as possible to this version. To do this, please go to our website and log in the menu tab. Create an account if you don't have one, and then using the portal, you were able to download the latest version. And then from this, please run as administrator, and it should install the update as well as carry over any licenses you have activated. And just briefly, a comparison from the version 1, because some people may be more familiar with the version 1 of the software. So with the version 2, we've added new magnifications that allows us to see even smaller particles in greater detail. We've also improved the lighting that allows these smaller particles to be seen better. We have added color cameras compared to just a mono on the Crystalline version 1. A lot of the settings for the cameras, including focus, are all changed in the software, which I'll be covering today. Where in the past with the version 1, we had the mechanical dials, which could be difficult to get particles in focus. We've also expanded our potential Raman integration, so we're now compatible with more customers, more providers of Raman. And we've also expanded the detection. So in the Crystalline, previously only the DLL, which was a old method for detecting particles. We now have the DLL plus the BLOB AI Pure and the AI Hybrid. And the analysis in the Crystalline version 1 was very basic, allowing for single crystal particle size distribution and D10, D50, and D90 trends, and a single frame elliptical shape factor. Now with the updated one, we're able to do particle size distribution evolution, as well as D10, D50, and D90 for those trends, as well as the elliptical shape factor and additional particle shape analysis. So first, I'll be starting with the camera guide, as we want to ensure that our particles are in focus and in the camera. So therefore, we can do the best detection possible and get the right information. So with the version 1, the camera was fixed settings. The only real options you had were backlight and front light intensity. And this was also fixed depending on what type of particles you're dealing with, whether they were opaque or filled in, as well as the manual dial for focus control. With the version 2, we have many different settings for our camera that allow us to change the what's being seen in the images, allowing you to optimize the camera settings for your given sample. So to access the camera settings, first you need to go, once you've programmed your experiment, you can go to the Run and Results tab. And within this, you'll see the small settings icon. Once you assign a reactor, you can click this and it will bring up the live image feed, as well as all the settings that are possible in the camera. From this, the front light and backlight are automated. So this will change according to what types of particles you have in sample automatically. Gain is set to automatic, as this will try to be minimized in order to have the particles most in sharpness. And then focus is always set to 0 at the beginning of every experiment. And this can be moved to the positive or negative. So when you first start an experiment and start running to see if you can get the crystals in view, the first thing to check is the camera magnification. So this is going to be highly dependent on what size of crystals you expect to be forming or what you're starting with. If you're having very large crystals, something like the 2 times or 4 times or 6 times magnification might not be optimal, as the crystal will be larger than the actual image size itself. So the detection won't really be as efficient as possible. Once you've selected the correct camera magnification, you then move on to the focus. So this changes the focal point of the camera and allows you to bring the particles into sharp view. Next, after you've changed the focus, you can move on to light period, which is essentially how long the pulse of light is during the image taking. This is set as 15 microseconds as the standard value, and this can be increased up to 35 microseconds. If you have particularly colored samples or dark samples or highly concentrated suspensions, increasing the light period allows you to get better viewing of your crystals. And then finally, if all these have been changed and the image still isn't to your liking, you can then change gains. So by toggling it from auto into manual, you can then change the gain settings, which is essentially how sensitive the camera is to the light in the sample. So if you have a very thick and dark sample, you can increase the gain, and what that will do is detect any of the trace amount of light that is in the sample. However, if you increase this too much, the image can become noisy as you start to see the individual pixels of the camera. So this is an example. This is L-ascorbic acid in methanol. And this is a couple hundred milligrams per milliliter in concentration. So once you start the camera settings, all these will be reverted back to the standard amount every time. You can set the bottom stirring or top stirring, whichever you're using here, and this will then change and start to agitate the sample. So first, we want to change the focus. So if we increase the focus to the positive value, this brings the camera focus to the front of the vial. And we can see here the grains and markings on the glass wall itself. So obviously, if working in labs, we're probably already wearing gloves, but it's recommended to wear gloves when handling the vial at any time, because you can still get your fingerprints or grease prints on the vial, and this will be visible on the camera. If we then go to the negative, we then start to go into the back of the vial. If you go too far, you'll have black images, black shapes moving across the camera. And this can be because you've gone too far deeper into the sample, and then you're seeing particles which are moving in front of the camera focal point. You can do this by sliding. So this would be moving the slide maybe large amounts at first, and then moving in smaller amounts to fine tune. Alternatively, you can put numbers in the side part here, press enter, and the slider will move directly to that position. So once the crystals are in focus, we can then start to look at the light period. So as standard 15 microseconds, if we increase the light period to now this is 23, we're starting to see the crystals a bit more clearly as the light catches off the edges. And then if we push right to 32, so the highest, the edges are really highlighted, but sometimes the definition on the other crystals is not as good. And then finally, we can look at gain. So as part of auto gain, it will try to minimize this value as much as possible to make it as sharp crystals as possible. By toggling this from auto, we can put it into manual, and then we can start to change the value. So if we go from auto to a low gain of about 3.9, the image isn't as bright, but we're still able to see the crystals of a very good definition. If we go to our higher value, so 10.9, we can actually start to see the crystals aren't really that visible because now the image is too noisy and actually the pixels are more visible in the frame. So ultimately, each sample is different. So it's recommended to play around with the settings to find optimal focal magnifications and other settings for your sample. Once you know these, it might be worth noting them down somewhere. So when you come back to using that specific position or that sample, you will then be able to automatically set those values again. It is also recommended to adding a prompt hold at the beginning of the experiment, so you can change these settings to ensure that you're collecting the proper images at the beginning. Furthermore, settings can be changed at any time during the experiment that allow you to then see if your sample suddenly becomes very dark. You can then increase light period at any point during the experiment, and you'll be able to see that reflected in the images. So once we've been able to get our crystals in the image and get them nice and sharp so we're able to detect them, we need to decide how we're going to detect them. And with the Crystalline version 2, we have 3 different methods. The first is the AI, which is our artificial intelligence detection method. This is ideal for dealing with known shapes. So we have a list of shapes which we have trained a database on for detection, as well as it will improve over time. So as we have more images and we generate more data, and customers, if they allow us to use their data, we're then able to train the database to pick up better shapes more easier. The second is the BLOB detection. So this stands for binary large object, which is based on a grayscale. This is good for finding small particles because these might be particles that are too small to have already be given a shape. So the AI might not be great at detecting those, as well as good as identifying unknown particle shapes that the AI might not have seen before. And then a third method, which is the hybrid, which utilizes both the AI and BLOB, but gives priority to the AI detection. So the AI itself is based on a database we have trained to look for specific shapes. So this is just an AI-generated example of if we've trained a database to look for stars and diamonds, then using this we'd be able to detect the stars and diamonds within this video. So how it works is in real time, we take the images generated on the Crystalline. We then run these through some pre-processing, that is lightening the images, making sure that the crystals are in focus and sharp enough based on light and contrast. It is then passed through a neural network, which is a trained database on over 1,000 images per particle shape. It then uses this to identify the specific shapes present in the image. It will then run through separation, so putting into specific categories based on shape and size. And then we have the outputs of classification on shape, and then the specific metrics that can be calculated from these images. So in the database, we have trained 5 different shapes. The first is non-convex, which is similar to the agglomerated particles, where we have multiple different jagged edges, giving to a non-uniform shape. And these will be classified as non-convex. Next, we have quasi-equidant, which is block or cubic crystals. Then we have needle crystals, which are defined by their high aspect ratio. Platelets, which are flatter to the images, 3D shapes, sorry. And finally, spheres. And then from this information, we can get additional characteristics. So from this, we get the particle size, which is the spherical equivalent diameter. The contour parameter, which is just the parameter around the outside of the particle. The contour area, which is the area inside the contour. The ellipses shape factor, which is the aspect ratios to dealing with the height and length of the detected shape. The convex hull, which is similar to the contour parameter, except we don't categorize this small indent in the crystal. So the way it's been described is if you take a rubber band and put it around an outside of some pins, it will pick up the outside parameter of those pins. And then the area, convex hull area, is the area inside of that convex. So now I'll move on to a live demonstration in the software, which will cover how to analyze your data. First, the processing of the images, so running through the neural network, needs to be done on the Omen computer, which is typically provided by Technobis. Once they've been processed on the Omen computer, the files can be opened on any laptop that has the advanced analysis license and can be analyzing anywhere in any computer. If you want to run the processing after an experiment, if it hasn't been done in real time, or on a version 1 of the Crystalline data, you need to disconnect the computer from the Crystalline in order to activate the processing option. So this is in the software, and to process the images after the experiment, you need to press the camera. It will then ask you if you want to run the advanced image analysis. And if you are on the Omen laptop, you would then be able to run the analysis. So when starting an experiment, to have the advanced analysis running in real time, ensure that the advanced image analysis button here on the details tab is selected. So in the analysis tab, we have 3 different side tabs. The image analysis, which is based on the version 1 analysis, and the particle size evolution, which is the new Crystalline version 2 analysis. Here you'll see the camera magnification, the pixel size, so the size that's in each pixel, and the focal volume. So this picture here is capturing 0.3 microliters of the volume. We can change the detection method that's shown in the graph at the top between the AI Pure, BLOB, and hybrid detection, as well as the legacy from the version 1 of the Crystalline. To start a new analysis, we need to right-click, do Add Time Selection. What you'll see now is a colored dotted line. as well as an image at the bottom, which is also colored the same color with the timestamp. So the images that are colored are included in this data set shown at the moment. I can then click and drag to expand the size of my data set. And then this includes all the images shown in the color below. If I want to standardize how much my data set is, I can zoom in and standardize how big this is. So once you've drawn your data size, you then need to look through images to identify which method of detection is suitable for your sample. So here we can click on the blob and you'll see it automatically changes the graph on the left. If I click the image again, it brings up the image in larger scale. And this, because I'm in view mode of shape, I can see what the software has identified all these shapes as. So in this case, it's saying these are plates, these larger crystals in orange. And I would not agree with this. I would say these are more cubic or block-like crystals. So these should be green. But it has picked up a lot of these smaller crystals. If you look at the AI-only analysis, it has identified correctly these green crystals above as cubic. However, it has not picked up all these small crystals, most likely because they're too small to be given a direct shape. And if I look at the hybrid case, it is correctly identified the crystals, large crystals, as quasi-ectant or cubic. And this is because the AI has been prioritized. But it has also picked up the smaller crystals as well. I can also change my view mode into size and see what size has been associated with these crystal shapes. Additionally, if I'm only interested in specific shapes or I'm wanting to remove shapes that I think aren't real, I can then click on Shape Filter and I can remove these from detection. And you'll see that the graph responds as I click these off and on. So at the moment, I'm in particle size statistic. By clicking on statistic, we can see the additional ones, such as elliptical shape factor, which is related to the aspect ratio, the contour area and parameter, a convex hull and convex area and a convex hull parameter, convexity and solidity. I can right-click the graph as well to turn it into logarithmic. And then by clicking the graph on the right, I can then see all the data that's been included in the analysis. From here, I can click them off if I want them to disappear. Clicking them again will re-add them to the graph. Additionally, each line has analysis of D10, D50, D90, and as shown in the table below. If I want to export these, I can right-click to copy the graph data to clipboard, which can then be placed in Excel. Or I can copy the graph image to clipboard and paste it directly into a presentation. So that covers the training in the software itself. I'm happy to take any questions you have on anything you've seen or any specific questions about how to use the software.